Hello and welcome to your lecture on Learning Outcomes 17, which focuses on volume and surface area. So your objectives for this lesson are to use a formula to find the volumes and surface areas of 3D shapes. Now, for level 2, that includes cylinders and maybe the odd sphere, but for level 1, you can just concentrate on basically cubes and cuboids, maybe a little bit on triangular prisms. Okay, you'll be given formula for 3D shapes other than cylinders. So you need to remember the formula for the cylinders, all right? Okay, let's get on with it. So, simple 3D shapes then. Okay, the volume of a 3D shape is the amount of space it occupies. Commonly used units of volume include cubic millimeters, cubic centimeters, and cubic meters. So remember, it is the amount of space it occupies. If I have a cube, the volume tells me how much space it takes up, okay? You can find the volume of some solid shapes, work out the area of each face, and then add them together. You need to learn the formula for these shapes. So, important formula that you need to know then for volume, okay? So, a cuboid, all right? A cuboid, such as one like this, means that you need to work out the volume, by doing the length times the width times the height, okay? So to work out the volume, length, width, and height. So we just do this value multiplied by this value multiplied by this value, okay? Now the volume is the amount of space it takes up, but the surface area is basically where we take each side of the shape and work out its area and add it together. So if I had a cuboid like the one you can see there, and I opened it up as a net, not very good at drawing that, am I? And I opened it up as a net, I'd have one side, I'd have a base, I'd have the other side, and I'd have a lid. I would also have two sides on the other, on the width side. Okay, when we find the surface area, we work out all of these areas and then we add them together. So to work out the surface area of a cuboid, like I say, work out the area of each face and then add it together. You could remember this formula: 2 times height times length plus 2 times height times width plus 2 times length times width. Okay, it's up to you if you want to remember that, or you just want to remember that you've got to work out the area of each face and add it together. Okay, however, the formula for the volume is nice and simple. Okay, so prisms. Now to work out the volume of a prism, like this one, we do the area of the cross section, okay, that's basically the area of the face, okay, and then we times it by the length. So in this case, it's a triangular prism. So we're going to work out the area of that triangle, and then we multiply by the length of the shape. There was a video on area and perimeter, so if you haven't watched it yet, go back and do that. Now, again, to work out the surface area of a prism, you work out the area of each face and then add it together. This shape would have a base like this, 2 sides like this, and then 2 triangle faces like this. You've got to work out the area of each of these and add them all together, and that will give you the surface area. Okay? However, the formula for the volume is simple. Area of the cross section multiplied by length. You must remember these formulas here. Okay? The surface area can be remembered because you're just trying to find the area of each section, each face, but the formula for the volumes you need to remember. Volume of a cylinder then. Volume of a cylinder is the same as the volume of a prism, we just don't realise it. Because what we actually do is we do pi r squared, which is the area of the face, the area of the cross section, and we multiply it by the height. Okay, so you're still working out the area of the face, like we did over here. It would just be a different formula because it's a circle. So it's pi r squared, and then we times by the height. Okay, So please make sure you remember that. Now, if we are doing a surface area of this shape, and I'm going to show you this again in a second, we would end up with a long rectangle which creates the circle, this section, okay, and we'd have two circles, one at the top, one at the bottom, which would make the top and the bottom. So you'd have to work out the area of each circle plus the area of the long rectangle to work out the surface area, and we'd add them together. Okay, so I'm going to show you some more examples of that shortly. Right, for now, write down the formulas for the volume because you're going to need them. So if you haven't already, do that, and then we are going to do a couple of questions. Okay, so first of all, calculate the volume of this prism. Okay, again, if you've not written down the formula, then you should have. Go back and write them down. I will put it here for you just in case. Volume of prism. So write it down now if you haven't already. It is the area of the cross section, which is the face. I'll put face there, times by the length. Okay, so pause the video, have a go, and press play for the answer. Okay, if you've had a go, let's look at this in detail then. Area of the face, this triangle here. We know how to work out the area of a triangle, don't we? Area of face or cross section. So it's a triangle in this case. Okay, the area of a triangle is base times height over 2. Okay, so the base is 7.5. We're going to times it by the height, which is 12, and then we're going to divide that by 2. Okay, so 7.5 times 12 is 90, and 90 divided by 2 is 45. So that's 45 centimetres squared for the triangle. And then for us to work out the volume of the entire thing, all we need to do is multiply that by the length. Okay, so 45 times 15, and that gives us the last part of the formula, which is 675 centimetres cubed, because we're working out volume. So area is squared, centimetres or metres squared. Volume is always in centimetres or metres cubed. It could be yards cubed, it could be millimetres cubed, it could be anything, but it's cubed. And the same for area, is always squared. Okay, so that is the volume of a prism. Not too difficult, hey? Right, some more complex solids. Now, these are very rare to come up in your foundation exam, but just in case. A sphere. To work out the volume of a sphere, okay, here's a sphere, which is like a ball. To work out the volume of a sphere, can we see here? We do 4 divided by 3 times by pi times by the radius cubed. So that's like 3 times. Okay, that's that one. So all you need to know to work out the volume of a sphere is the radius. Everything else is given because we know that the fraction at the beginning is 4 divided by 3. We know that pi is on your calculator, and we know that whatever the radius is on the picture, you can put in here. And you can just put all of that into your calculator and it'll give you an answer. The surface area of a sphere is 4 times pi, sorry, that's meant to say 4 pi r squared, okay, which is 4 times pi times the radius times the radius. So again, all you need to know to work out the surface area of a sphere is this formula. And a lot of the time they'll probably give you those ones because they're like the harder ones. So they'll probably give you the formula. So all you need to know again is the radius, okay, because you know 4, you know that pi is on your calculator, so you can use it, and then you can just put the r in twice. So it shouldn't be too difficult for you to work out the surface area of a sphere, okay. A pyramid, okay, the volume of a pyramid is quite easy, okay. Here's an example of a pyramid, okay, ignore the second bit of writing for now. The volume of a pyramid is a third of the area of the base times by the height. So if we're given a base, we can work out the area of this. Let's say that's 5 meters by 5 meters. Okay. The volume of a pyramid would be a third, or 1 divided by 3 if you like, times by the area of this base. Well, the area of this base would just be 5 times 5 because it's a square. So that's 25 meters squared, times by the height. Let's say the height was 8, okay? It would then be times by 8. So in your calculator, you can just do 1 divided by 3 times 25 times 8, and it will tell you the volume, okay? You've just got to remember these formulas and you put the correct numbers in. All right, so the only other thing is working out the surface area of a pyramid, because the surface area of a pyramid, you'd have to draw the net, or at least try and understand how many sides there are. So this base here is this, and because it's a square base pyramid, it will have 4 triangles, okay? So if this length was 5 by 5, 5 by 5, okay, then we know that this would be 25 meters squared. And let's say the height was 8, like I said before, then we can work out all of these triangles by doing 5 times 8, which is 40, divided by 2, because it's base times height over 2 for a triangle. So each one of these would be 20 meters squared. Okay, just giving you an example here. So altogether the triangles are 80 meters squared plus the 25 meters squared for the base. Okay, that gives you 105 meters squared for the surface area. All right, so you're just finding the area of all the shapes. You'd find the area of this, and then they'll all be the same, so there'll be 4 of those, and then the area of the square in the middle. Okay? But like I say, the most important thing is to remember the volumes. Make sure you remember the volume formulas. Okay? Sorry about this one, 4 pi r squared, not 4 pi squared. Okay, more complex solids still. Now then, I mentioned earlier the surface area of a cylinder, and I just want to go through that again in a bit more detail. So here is a cylinder, okay, and we should know how to work out the volume of a cylinder because it's just pi r squared for the top circle times by the height, okay, nice and easy. However, we have to work out the surface area of a cylinder. Now, you can remember the surface area of a cylinder by remembering this formula if you want to. Okay, 2 lots of pi r squared, which means you've got 2 lots of these, plus pi times d times h. Okay, because pi d is that length there, and h is that length there. Now, that sounds complicated, so instead I don't really do that. Let's say we've got a cylinder here with a radius of 4 and a height of 6 in meters, okay? So that means if I use this as my diagram, if I use this as my diagram here, okay, that means that my radius here is 4 and my height here is 6. I want to work out the surface area of this circle first. So area of circle would be pi r squared, okay? So I'm going to do pi times by 4 squared, or pi times 16, all right? So if I worked that out, pi times 16, sorry, I'm just doing it on my calculator so that I can give you an accurate answer, is 50.26548, blah, 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 blah. I would then have to times that by 2 because I've got 2 circles, which is where you get this bit from, okay? So if I times that by 2, it gives me 100.530964. Okay, so let me just put that there, and I'm going to round it. Sorry, I'm just thinking for a second. I'm going to round it to 100.53 meters. Oh dear. Meters squared to 1 decimal place. Okay. Now then, the reason it gives you this part here is because we need to know this length in order to work out the area of this cylinder. To work out that length, we need to know the circumference of the circle. Okay? Because the circumference of the circle is the same as this length because it wraps all the way around it. Okay? So that's why you've got pi d times h. So pi times d will give us the measurement for this length here. So the diameter is 8. So I'm going to do pi times 8. That gives me 25.1327412228, and I'll just leave that there. Okay, so I know now that my length of the rectangle is that 0.133. I've rounded. The reason we then have the h is because if that's the length for that, to work out the area, I've got to multiply it by 6. So I'm now going to times that by 6. Okay, so 150, oh sorry, let me write it down what I've done so you don't get confused. Times by 6 equals 150.79, let's do it this way, 150.8, okay, centimeters, no, again, sorry about this, meters squared, okay, to 1 decimal place. All right, so I've worked out the area of my 2 circles and I've worked out the area of my rectangle. I now need to add them together. So I'm going to add on I'm going to add 150.8 to 100.53, giving me a total surface area of 251.33 to 2 decimal places. Okay, I probably should have rounded to just 1 decimal place, so 0.3 meters squared to 1 decimal place because I've rounded to 1 decimal place everywhere else. So I'm trying to be consistent. So you can see now where the formula comes from. I've got 2 lots of area of a circle, so I've got 1 there and 1 there, and then I've got 1 lot of pi d because I need this length, okay, times by the height because that's how you find the area of a rectangle. Okay, so I hope that makes sense and you can use that formula now to work out the surface area of a cylinder. Okay, so here is another example. I want you to pause the video and have a go at this and press play and we'll go through the answer. Okay, so if you've had a go at that then, I'm just going to write down, I mean you should have written this down anyway, but I'm just going to write down here 2 pi r squared plus pi d h, okay, because that's how we're going to work out the surface area. So let me change my colour pen. I want 2 lots of pi r squared. So that's 2 lots of pi times the radius squared. Remember the radius is 3 because the diameter is 6. I've then got to add to that pi times the diameter, which is 6, times by the height, which is 12. Okay? All right, so now that we've got a formula and we can just put it all in, it's much easier. Now, I am going to do a little bit of working out here before I do the calculations with pi. So I've got 2 times pi times 9, because 3 times 3 is 9. And then pi times 6 times 12. Well, 6 times 12 is 72. So I'm going to put that in there. Okay. So then, in my calculator, I'm going to do 2 times pi times 9. And that gives me 56.54866. We'll leave it there. Plus, and then I'm going to do pi times 72, which equals 226.19467,105. Let's make it 6, we'll round there. Okay, and then I'm just going to add those both together. So if I do that, now I'm just using some of the longer numbers for now, and then I'll round right at the end. Okay, if I add them both together, it gives me 282.7, well, 743339058. So I'm going to round it to 0.7, okay, centimeters, that is cubed, squared, because we're doing surface area, not volume. And that would be to 1 decimal place. Let me write that 1 again, it looks a bit like a 2. 1 decimal place. Okay, so it's not too bad once you've got the formula and you can just put everything in. If you can't remember the formula, remember this elongates out into a rectangle, so you've got to try and find this length, work out the area of the rectangle, and then work out the area of 2 circles. Okay? If you can't remember that, that's what you've got to do. Right, here is a question about volume of a cylinder now. So remember, the volume of our cylinder is pi r squared h. So it's basically the area of the circle times by the height. But this question says, if the volume of this cylinder is 205 centimetre cubed, work out its height. Use 3.142 as pi, or the pi button on your calculator. Give your answer correct to 3 significant figures. Okay, if you feel like you want to have a go at that, then pause the video and have a go, and then press play and I'll go through the answers. Okay, if you've had a go then, what this is saying is, it's saying that the volume is 205 centimetre cubed. So volume is pi r squared h, but we know the volume is 205, which is equal to pi times r. Okay, r is half the diameter, remember, so we need to half 5.6, which is 2.8 squared, times by h. We don't know h, we're trying to find h, work out its height. Okay, we also know that pi, I'm going to replace pi here with 3.142. Okay, because that's the number it's telling me to use, or I can use pi on my calculator. So what I've got here, again, I'm just going to write this out again. I've got 205 equals 3.142 times, and then I'm going to do 2.8 squared, because I like to just cancel it down a little bit and make it a little bit easier for myself, times by h. Okay, so now all I need to do is, I could even cancel it down even further, and I could do this here. So I can actually times that by pi, leaving me with 205 equals 24.6300866404. Okay, times by h. So all I've got to do now is 24 times something gives me 205. That's what that means. Okay, so if I actually reverse that calculation now, I've got a formula, I've got an equation, remember. So I'm going to reverse that calculation. I'm going to divide by 24.6300866404. Okay, and if I do that, 205 divided by, now it depends how you want to keep this on your calculator, but it's better to use a longer number. I mean, I'll show you another way in a minute. And that gives me 8.32 315. Okay, so that's telling me that that's H. Okay, so it says to give our answer correct to 3 significant figures, which would be 8.32 centimeters to 3 significant figures. Okay, now then, there is another way we could do this, because you might not want to do all of this simplifying to get these long numbers, but at the same time I'm looking at it thinking it's probably easiest for you. I am going to quickly check though that my volume of this cylinder gives me this. So pi r squared h equals 205. Okay, and apparently my height is 8.32. So pi times by the radius, which was 2.8, remember, from there to there, squared, times by 8.32 should give me 205. So let's check. Pi times 2.8 squared times by 8.32. Yes, it actually gives us 204.922, which, because we've rounded, then that will be about right. We're almost at 205. So we know we've got the correct answer. Okay, now quickly going back, if I get rid of all of this, okay, going back to here, because I don't want you to be confused. What you could have done was we could have divided by 3.142. Okay, so 205 divided by 3.142 gives us 65.245. Okay, and that equals 2.8 squared times h. All right, because I've divided by 3.142, it's moved it over to this side. We've technically done the same to both sides. I still would have had to do 2.8 squared because I can't square root that number without having to square root h, and I don't want to do that. So I now know that 65.245 equals 7.84 times h, because I've squared it. And then I will divide this by 7.84 to give me h on its own. And 65.245 divided by 7.84 is 8.32266, which when rounded is 8.32 centimeters to 3 significant figures, and that's what we got before. So we know we've done it the right way around anyway. Okay, I just wanted to go through that other method with you there. Okay, we're not got long left. We've not got long left. A few exam questions I do want to go through, but until then, let's just have a quick look at converting units of area and volume, okay? Now then, before you calculate an area, always check that the measurements are in the same units, okay? So sometimes they might give you something like this, and they'll say that's 10 meters, and this is 105 centimeters. That means that that's 1.05 meters. So you need to make sure they're in the same unit before you do anything with them, because you'll get the wrong answer. Now then, 1 meter is the same as 100 centimeters. So 1 centimeter squared is 100 centimeters times 100 centimeters. So we need to know that 1 meter squared is the same as 10,000 centimeters squared. Okay. Now you need to know that because sometimes it will ask you to convert 8 meters squared into square centimeters. Okay. Remember, 1 meter squared is 10,000 centimeters squared. And if 1 meter squared is 10,000 centimeters squared, then 8 meters squared must be 8 times 10,000 centimeters squared, which is 80,000 centimeters squared. So 8 meters squared is the same as 80,000 centimeters squared. Okay? Because in every meter, we have 100 centimeters. Okay? So if it's 8 meters squared, We need to make sure we're converting in the right way. Okay? Now, another example. If we have so that's area, but if we have volume, okay, we need to make sure that we remember that if 1 meter is 100 centimeters, 1 meter is 100 centimeters, then 1 meter cubed is 3 lots of that. Can you see from the diagram? Okay. So 1 meter cubed is 100 times 100 times 100 centimeters. So 1 meter cubed is actually 1 million centimeters cubed. Okay. So if you're being asked to convert 12 meters cubed into cubic centimeters, you need to remember this conversion here. And if you can remember that 1 meter cubed is 1 million centimeters cubed, then 12 meter cubed must be 12 lots of 1 million centimeters cubed, which is 12 million centimeters cubed. Okay? If you can remember this conversion here, and if I go back a slide, this conversion here, then you'll be okay with those in the test. Okay? You won't really be asked to do any more than that. All right, let's look at some exam questions then, and then we're done. So here we have got a triangular prism. You're being asked to work out the total surface area of the triangular prism. State the units with your answer, it says, and you get 4 marks. So pause the video, have a go, and press play for the answer. Okay, if you've had a go, let's go through this. Now then, remember, surface area, it means we need to find all of the faces, okay? There isn't necessarily a formula for this, but if you can see, we've got a face here, okay? Got that one. We've then got one on the bottom, and then we've got the one at the side, okay? So, the first face, face 1, is 10, if I show you this better now, is 5 centimeters down there and 10 centimeters across there, and it's just a rectangle. Face 1 is a rectangle, which means we're going to do length times width, which means we're just going to do 10 times 5, which equals 50 centimeters squared. Okay? We've then got this base rectangle. Okay, so face number 2 is also a rectangle. And so we do length times width, but this time it's 10 times 4, which is 40 centimeters squared. Now then we've got this back rectangle here. Okay, and this back rectangle is going to be 10, because this is still 10 because of this, by 3. So face number 3 is also a rectangle. So we're going to do length times width, but this time it'll be 10 times 3, which is 30 centimeters squared. Okay, finally then we have these 2 triangles. One triangle there and one triangle there. Now, if you're clever, you'll notice that these 2 triangles come together to make a square. Well, it's actually a rectangle. Okay, it has a base of 4 centimeters and a height of 3. We don't need that 5 because that's giving us the diagonal length, and we never use that. So if I just show you that I've drawn this triangle, then this other triangle fits nicely on top of it. And normally what we would do for a triangle is we'd do base times height, and we would half it, okay, which is giving us half of the rectangle. But this time we don't have to do that because we've got 2 of them. We can just do 3 times 4, which is 12 centimeters squared. And if I wanted to, okay, I'll just show you. If I wanted to, I could do, well, that's 4, that's 3. And I could do my area of my triangle, okay? And if I did my area of my triangle, it would be base times by height over 2. 4 times 3 is 12, over 2 is 6. Okay, let me just rub that out a minute. Sorry. Over 2 over 2 is 6, okay? Because we divide by 2, that gives us 6 centimetres squared for this first triangle here. So, but then I've got another triangle, so I'm just going to end up doing the same thing again, and I'd end up with another 6 centimetres squared. Well, altogether, it makes 12 centimetres squared, doesn't it? So I can just do 3 times 4 and just not half it, giving me 12 centimetres squared. Okay? Now, what I'm going to do is I'm going to write here, triangles equal 12 centimetres squared. And then all I've got to do is add these values all together now. So 50 plus 40 plus 30 plus 12. Okay? 50, 90, 120, 132. 132 centimetres squared for the total surface area. All right, if you're not that quick at adding, you can write it out like this if you want to. So that column is just 2, and then this column came to 13. All right. Okay, so hopefully you understood that question and you got it correct. Surface area is just finding all of the faces and adding them together. Okay, this one is asking you for the total surface area of this L-shaped prism. Okay, have a go at that one and then press play for the answer. Alright, if you've had a go. Total surface area of this prism. Now, we have to be careful. We have to remember what there is here. Okay. The first thing I'm going to think about is this L shape here. I'm going to work out the area of this L shape. And I've got 2 of those. To work out the area of this L shape, what I could do is I could go across like this. And I know that this is going to be 1 centimetre. I know it's going to be 1 centimetre long because it tells me at the top. But I also know it's going to be 2 centimetres here, down there, okay? Because it's 3 centimetres in total and that's 1 centimetre, okay? So this small rectangle there is going to be 1 times 2, which is 2 centimetres squared. And the longer rectangle down here is going to be 5 times 1, which is 5 centimetres squared, okay? And then we add those 2, so the total is 7 centimetres squared for the L shape. So that whole L shape, okay, is 7 centimetres squared. I've actually got 2 of those because there's another one at the back here, giving me, 14 centimetres squared. L shapes. Okay, so there's that bit done. The next thing I'm going to do is I am going to work out the base of the shape. Remember, we can't miss that out. So I'm going to also do that in blue, the base. The base of the shape is just 6 times 5. Okay, because technically that base will go along there and down there as well. Actually it'll be like that. Okay. So underneath, the bottom of the shape will be 6 times 5. 6 times 5 is 30 centimetres squared. Okay, and that's for the base. Done. Now, the back, meaning this bit here going across there, okay, behind, at the back, okay, let me put this in, back, is 3 times 6, because 6 is this length here, which means it's also going to be this length here. And I need to work out the back of the shape. Okay, so 3 times 6 is 18, so that's going to be 18 centimetres squared for the back. All we've got left to do now is this bit. In fact, I won't do it like that. I'll show it you really clearly. We've got this section to do. We've then got this section to do. Then we've got this section to do. So I'm just trying to show you in the best way. And then we've got this section to do. Okay, so this section in orange is just going to be 1 times 6, which is 6 centimeters squared. The bit in red is going to be 4 times 6, because this length here is still 6. Okay, which is 24 centimeters squared. The bit in green, now just be careful, remember this here, this length, either side was 2. Because in total it's 3, and this is 1. So if that's 1, this bit must be 2. So that'll be 2 times 6, which is 12 centimeters squared. And then finally, the section in blue at the top is just going to be 1 times 6 again, which is 6 centimeters squared. Okay, so we've got quite a lot there. I'm just going to make myself some space, because what we've got to do now is we've got to add them all together. We've got 14 centimeters squared for the L shapes, 30 centimeters squared for the base, and 18 centimeters squared for the back. So I'm going to start there. So if I add them up, I've got 12 there, and then 1, 2, 3, 4, 5, 6 there. So that's 62 centimeters squared for these bits at the top here. Then I've got 6, 24, 12 and 6. So these two 6s I'm going to turn into a 12. And then 24 and 12, just to make it quicker to add up. So then I've got 8 there and 4 there. So that's 48 centimeters squared for those bits. So then if I add them together, we've got 10 there and 10, 11 there. So it's 110 centimeters squared. Don't know what's going on with my pen and everything, it's flashing. Okay, that was a tricky one, I'm not going to lie. All right, so very good work. Let's do, we've got 2 more questions and then we're done. Okay. Oh, I know why it's flashing, because it's not quite in shape. There we go. Right, here is another question. This one says, the diagram shows 2 fish tanks, each in the shape of a cuboid. Finley fills both fish tanks with water. Which fish tank holds the most water? You must show all of your calculations. Okay, so have a go at this one. Pause the video and do it, and then press play for the answer. Okay, if you've had a go at this, then the basic premise for this then is to find the volume of each tank. So we've got tank A, and remember when we do volume of a cuboid, it's just length times width times height. So we're going to do 95 times 30 times 35. Okay, now if we do that one for this one, 95 times 30 times 35 gives us 99,750, and that's in centimetres cubed. Then if we look at tank B, we're going to do the same, and that means we're going to do 65 times 35 times 45. Again, you get 4 marks for this, so it's not a bad question. And that gives us 102,375 centimetres cubed. Now, it doesn't ask us to do this, but you could change them into litres if you wanted. Okay. However, it's not necessary. So you could just say that tank B holds the most, because you've worked out your calculations. The other thing you could have done if you wanted, now 1,000 centimetres cubed equals 1 litre. So what you could do, if you wanted to, you don't have to do this, is you can do 99,750 divided by 1,000, okay, which gives you 99.75 litres, okay. And then you can do 102,375 divided by 1,000, which gives you 102.375 litres. Again, it doesn't ask you to do that, so you probably don't have to. But you can say tank B holds the most with 102.375 litres. Okay? So not bad at all. Tank A looks like it probably holds more, but it doesn't. All right, last one then. Work out the volume now of this prism. This is a prism. Try and remember what I said about prisms, the triangular prism particularly, and then I also mentioned the same thing about a cylinder. How might you work out the volume of this prism easily? Press pause, have a go, and press play for the answer. Okay, if you've had a go, a prism, we work out the area of the cross section and then we multiply it by the length. So I don't want you to have done too much for this. Your main thing you've got to do is work out the area of this L shape here. Okay? Now, remember last time we worked out the area of an L shape? Okay, what you can do is you can cut it off there. So you end up with 2 times 9 on the bottom, because it's a rectangle. And then here, it's not going to be 7, because actually that's 2. So this must be 5, because 5 plus 2 makes 7. So this would be 4 times 5. Okay, so if I label that A and that B, I can do A equals 4 times 5, which equals 20 centimetres squared. And B equals 2 times 9, which is 18 centimetres squared. So the total would be 20 plus 18, which is 38 centimetres squared, for the area of the face, the area of the cross section. Volume would then be the area of the cross section, which is 38, times by the length of the shape, which is 10. Which equals 48 centimetres cubed. All right, so that one wasn't too bad at all, was it? So just be careful when splitting up your shape. Okay, 7 was the whole measurement going all the way down. And if this was 2, because it's 2 here, look, then this bit must have been 5. It is not drawn accurately. They will do that on purpose to try and trick you, okay? Okay, so I hope you feel confident now using the formula to find the volume and surface area of different 3D shapes. And I hope you can remember the formula for finding the volume of a cylinder. Okay, again, that's mainly for level 2. All right, so well done in this lesson. This wasn't an easy one. And I look forward to seeing how you do on the assignments based on this. I'll see you next time.